Okay, I'm going to go straight into it today. We're in the geometry book, the green geometry book, and we're working on the, last time we were working on 9-4, perimeter and area and the coordinate plane. Let's see, I've got a few people I've got to do, get in here on this. Okay. All right, so we're on 9-4, perimeter area and the coordinate plane. Now, we took notes last time and we filled out the entire sheet just about it. We had wound up with example 3, 617, finding the area by subtracting. And we almost got through down here. If you have your notes from last time, we can wrap up this real quick. It's very fast. This was an 8x7 here. And then all we had to do is subtract the 1, 2, 3, 4 triangles. We're going to take away 4 triangles. All right. And the 4 triangles, I'm going to label them as 1, 2, 3, 4, like that. So we're going to do triangle 1. His height was 1, 2, 3, 4 by 1, 2, 3, 4. So we have one triangle is a 4 by 4. And remember, the area is cut in half. All right, that's triangle 1. Triangle 2 is a 3 by 2. Triangle 3 is a 2 by 3. Wait, let's see what this is. 1, 2, 3, 4, 5. It's a 2 by 5. Okay. And then triangle 4 was we're going from this dot to this dot. 1, 2, 3 by 1, 2, 3, 4, 5, 6. 3 by 6. So if we figure out all 4 of these triangles, half of 16 is 8, half of 6 is 3, half of 10 is 5, half of 18 is 9. So we add all this up. If you add all this up together, that's going to be 8 plus 8 is 16, plus 9 is 25. We're going to take away 25 square units. So we had 56 square units, and we're taking away 25. That gives me 31 square units. On example 3, page 617, and something happened here. I must have miscalculated or whatever, but I'm just showing you that's how that works, okay? So that's, apparently I miscalculated something that's supposed to be 29, but hey, no biggie. I'm not worried about it, okay? All right, let's go on to, let's go to number, well, now we're not going to do section 9.4, example 4. We're going to go on to page, or section 9.5 today. I am going to, yeah, let's go ahead and do section 9.5 now. I'm going to hit a couple of high points here and there on 9.4. And let's discuss some things, because this week I'm planning on reviewing y'all on chapter 9. And so you have like a blob here. You're trying to figure out the area. You could box it off and find the total area of the outside of the shape, and then just take off all the little triangles and stuff like that that you estimate it to have later. Very simple, nothing to it. Now let's go on to 9-5 real quick, and let's talk about this. Let's start a new section today. I'm going to write my name here at the top. New page of notes. Today's date, I don't even know what it is, 4/27. Okay. Now, we're doing 9-5. Effects of changing dimensions proportionally. I don't know if any of y'all have had any experience with editing photos and stuff like that. Whenever you edit photos on a computer, you usually you have one or two options. like you can the length and the width. You can resize them by percentage or by pixel, and it's kind of like what we're talking about today, is where when we resize this by 200%. So in other words, we double this, the length's length and the width's width. If we double both of those, that's multiplying it by, we're resizing it, scaling it up, okay, by a factor of 2. Or you can resize something by pixels, like however many pixels this is, resize it by a certain number of pixels more. But we're changing dimensions proportionally. In this case, what you do to one side, you need to do to the other side, okay? You don't just change this length, or you'd wind up with a funny looking shape. Like if you had a picture of a Coke bottle, and you were to resize it just by this dimension only, and change nothing else, what you'd have is a really tall bottle, look like that. So it doesn't look the same, but it is resizing it. That's not proportionally. That's just changing the dimension. Okay, so let's go down to 9-5 and talk about what page we're on here. 622 is the page, so I'm going to put page 622. All right, and so let's talk about example 1. There are no, if you'll notice here, there's no real like new discussion that we need to have, like new theorems, new stuff like that. There's we're just going to hit the objective real quick and then talk about example 1. It says we're going to describe the effect on perimeter and area when one or more dimensions of a figure are changed. Then we're going to apply the relationship between perimeter and area in problem solving. All right, so this is going to be a kind of a problem solving kind of chapter section. All right, so let's basically, okay, let's see how many we've got. We got 3 examples. Yeah, we'll do 3 examples and maybe a couple of extra problems, and we'll hit the road. Okay, so we're only going to hit the high points here, and because this is a very straightforward topic. It says the effects of changing one dimension. Describe the effect of each change. So we're going to do example 1 on the area of the given figure. So we have this area here. If you have this shape that looks like this, it's a parallelogram because it's parallel here and here. And we've got this, this dotted line going off like this. That means that this length right here and this length are, they're called perpendicular to one another. All right, if this side over here is 12, then guess what? I bet you this side over here is 12. Let's see what the problem says. It says the height of the parallelogram is doubled. So the original dimensions are, this is a 12 by 9 rectangle. And so my area is base times height, 12 by 9. That's going to be 90 plus 18. That's 108 centimeters squared. Sorry. No, wait a second. Something's funny here. I don't know what's happening here. They must have mistakenly put some meters and then put centimeters over here. Well, there must be an issue here. Okay, so I'm going to put centimeters for all that, and so we got 108 centimeters squared. And now we're going to double the height. So we're doubling only the height, not both. So this is not proportional, right? This would be like really changing the way the shape looks. So if we got that height was 9, right? So half of 9 is 4.5. So this is, oh, sorry, the height is doubled, not cut in half. I made a mistake. So the height is doubled. Okay, so the height is doubled. So that's going to be 12 times 18, which is 12 times 18, which is 216 centimeters squared. So what we've got, you see how there originally our shape was 108 centimeters squared. Now we have 216 centimeters squared. What that means is if you were to stretch this out, double the distance this way, right? If you were to go all the way out here and, you know, almost double this direction, you would wind up with a bunch of squares going out here, a bunch more. So they almost literally double the squares that we had. So we have literally doubled the amount. So 108 plus 108 is 216. See that? All right. So now let's go over to the part B of this and discuss what this says. It says the base length of the triangle with vertices A, B, and C is multiplied by 1/2. So the base length, okay? So let's see if I can brighten this up and you can see this a little better here. Okay, I'm gonna just draw this freehand here. So I'm gonna go out 1, 1 and put a dot here. Call that point A. And I'm gonna go out to 6, 1. 6, 1 is going to be here. That's point B. And then we have 3, 5. So I'm just freehanding these things, guys. And you can do the same thing. Very simple. If you're not an artist, it's okay. So here's the height. The height is 4. And the base is 5, right? So we have a 1, 2, 3, 4, 5 across the bottom. 1, 2, 3, 4 across the top. That's perpendicular. That's a base and height. We all know the dimensions of a triangle. The area of a triangle is this. So we're going to have area equals 1/2 times 5 times 4. Half of 4 is 2. So that's 10 units squared for the actual triangle here. So if you went over here and counted all these little squares inside of here, you could count 10 squares, adding up the little extra triangle pieces, okay, and putting them all together. Now we're supposed to change something, change a dimension, the base length, right? The base length, which was 5, we're going to multiply it by 1/2. So in this case, we're going to change we're going to multiply 5 by 1/2. This is not proportionally, right? This would be like this. You'd have an oblong shape. So if you multiply these two fractions together, you get 1/4 times 5 times 4. The 1/4 and 4 cancel out, so the answer is 5 square units. Okay? So rewriting that, you get the 5 is your answer. Okay? So if you cut this in half, this shape in half, what you would get would be a shape that looks kind of like this, and they're saying that this new shape would be half, not 10 units, but 5 units, half of the area of the original. So if you cut 1 by half, then you cut the total area in half. Over here, if you double one side, you're going to double the area. It's just a matter of, it's like if you had 2 blocks put side by side, well, that's double the size of the original block, right? If you have 1/2 of the length of one block, then you have 1/2 of the area of the block, right? So it kind of makes sense. So let's go back and work on example 2 now. Example 2 is, let's read the topic here, and I'll zoom in and get it all nice and easy to deal with. And we're probably going to wrap up a little sooner than normal today. So let's see what we can read here. It says, helpful hint here, if the radius of a circle or the side length of a square is changed, the size of the entire figure changes proportionally. All right, so now we're going to talk about circles, right? And we got to remember the circle formula, which is A equals pi r squared. Circumference, which is the length, like it's a sort of snake. If a snake was wrapped around in a circle, if you stretch that snake out into a long line, you'd see that his length would be 2 pi r. Radius would be 9 here, right? So we're going to have to deal with working on the next step. So let's go through and write down. I'm going to pull this off to the side and put only my. Now, if you have your book with you, you can read along with me. I'm just going to fill in the gaps here, and you just kind of walk with me here. Okay, so we're on example 2. I'm going to read this out. It says, Describe the effect of each change on the perimeter or circumference in the area of the given figure. Section A says the base and height of a rectangle with a base 8 meters and a height 3 meters are both multiplied by 5. So we have a rectangle that looks like this. All right, and so we have a base of 8 meters and a height of 5 meters. And so what they're saying is, what if we changed something here? And it says the base and the height of the rectangle are both multiplied by 5. So the original dimensions would be, the perimeter would be 2 lengths plus 2 widths. All right. And so we have 2 times 8 plus 2 times 5. So the perimeter around this shape would be 16 plus 10, or 26 meters. Okay. Now, how does that affect if you multiply both dimensions by 5? Well, if I took this dimension right here and this dimension and multiplied it by 5, let's rewrite that. Okay. So we're going to put perimeter equals 2 times 5L plus 2 times 5W. All right. So we've got perimeter equals 2 times 5 times 8 plus 2 times 5 times 5. That's going to be 2 times, let's see, 2 times 40 plus 2 times 25. That's 80 plus 50. That's going to be 110. Wait, that's not right. 80 plus 50 is 130, isn't it? All right, let's see. Let's see. All right, so 80 plus 50 equals 105. Okay. So something happened with what I just did. So let's look at this book real quick and see where I made the mistake, because I'm reading this kind of funny. Let's go back and look at this real quick. It says you had the original perimeter, which was supposed to be 24 meters squared. Yeah, something's up here. I got my dimensions off or something. Oh, it's 8 and 3. I'm sorry. So my height was, my base was 8. My height was 3. I wrote 5 instead of 3. So let me go rewrite that. Let's go back here and rewrite this. So let's change this 5 to a 3. That makes that a 6, and this makes this 22. Okay, so that's 16 plus 6 is 22, yeah. So we got 22 meters. All right, and so now we did not talk about the area here yet. All right, and so let's go back up here and work this out. So our 5 needed to be a 3. We're multiplying 5 by 3 because we're multiplying this dimension by 5 and this dimension by 5. So in other words, we're changing it proportionally. All right, and so we've got 40, let's see, 15 there. So 80 plus 30 is 1, okay. 80 plus 30 is 110. Now that's better. This matches up more with what the book has. So if you're following me with the book, that's fine. Now let's go do the area real quick, which is base times height. This one's a little bit easier because it's just 8 times 3, which is 24 meters squared. Now we're going to change the base by 5, or multiply by 5. And we're going to multiply the height by 5. So we have 5 times 8 and 5 times 3. So that's 25 times 24. That's a lot. And it's going to be 625 minus 25. It'll be 600 exactly, probably, right? So we got 5 times 8 times 5 times 3. 600 exactly. Okay. All right. So that changes in other words, if you stack this, if you had a block and you stacked it 5 blocks high, like that, and you had a block this way, and you went 5 blocks this way, and then you filled in the rest, all this right here. This is all the area that you would have of that big rectangle. And that's why the number is so much bigger, because you're actually multiplying it. substantially. So we're going from a 24 meter square block to 600 square meters just by multiplying this direction by 5 and multiplying this direction by 5. Okay. All right. And so there's how it changes perimeter. It changes pretty substantially on the perimeter, but it changes a lot more in the area, okay, of this shape. All right, let's go do a circle. Circle, let's talk about the dimensions of this circle here. It says the radius of circle A is multiplied by 1/3. So we're going to take this radius here and we're going to basically divide it by 3. So 9 divided by 3 is 3. And that's where that comes from right there. And we're going to see how it affects the circumference and the area of this shape. So we're going to start off with example 3. Example 2, part B. This was example 2, part A. So now we're going to come down here and work out circle A has a radius of 9, and we're going to change the size of this circle by taking it and dividing it by 3. So in other words, what's the new circumference in the new area? Obviously, if this were a snake, you'd have a much smaller, like, it's proportional, right? But it's not the same size. So this distance around would be smaller right here. And then the area would also be smaller too. So let's talk about area of the original and the area of the new. All right, so the original was r squared and the new one was where the radius was divided by 3. So we've got pi equals 9 squared. That's going to be 81 pi. And I'm going to leave it just like that. I'm not going to worry too much about the dimensions. And that's supposed to be in inches. Okay, and so this is pi times 9 over 3 squared. So that's going to be 3 squared is 9. This is 9 pi inches. So the area has basically really cut down quite a bit. All right, so now let's go down to the circumference of the circle. So that's going to be 2 pi r. Notice these formulas are very similar, just the 2's in a different place. All right, so the original is 2 pi r. The new one is going to be 2 pi r over 3 because we're dividing our radius by 3, all right? And so we're going to put 2 times pi times radius. That's 18 pi inches. And then this other one is going to be 9 over 3. So that's 3 times 2 is 6 pi inches. So there's how the difference between those two. Notice that's divided by 3 in this case. If you divide the radius by 3, then this is divided by 3. And you remember, with area, you're talking about squares. So if you divide something by 3, you're dividing by the square root, 3 squared. If you divide by 3 squared, it'd be divided by 9. So 81 divided by 9 is 9. So that's where that comes in. So this is square rooted, and then this is, divided by 3 squared, and this is just divided by 3, okay? In this case right here, this is multiplied by 5, and then this is multiplied by 5 squared, right? So area is squared, perimeter is not squared. So we're almost through with our notes for today. I'm gonna back this up and give y'all a chance to look at this. You can snapshot that and take a picture if you want. But I'm going to fill in this last little gap down here with what we need to work on for tomorrow. We're going to talk about effects of changing area. 9-5. Now let's zip through real quick and talk about what's happening over the next couple of days. So we have 9-5. Let's flip through and see how many sections we have left. I just want you to see what's going on. We have 9-6. We're going to do geometric probability, and then we'll go into the review. Okay, we'll do a review on Wednesday, and we'll just go through this section right here and just hit all the high points. Do only the evens possibly of these sections here. All right, so we're going to hit chapter 9 pretty soon, finish up. We got one more section today, one more little thing I'm going to talk about, and then we'll hit the road. Okay. All right. So let's talk about the effects of changing area. One last little note that we're going to add to our notes is a square has side length of 5 centimeters, and area is tripled. If the area is tripled, what happens to the side length? So in other words, we're going to go backwards here. So let's pull this over here and draw this out. So what if we start off with example 3? What if we start off with a square with, let's see what it says, a square that has a side length of 5 centimeters, and obviously a square is going to have the same length all the way around. So it's 5 centimeters all the way around. What if the area is tripled? In other words, what if I took 3 of these blocks and stacked them? What would happen if I, made a larger square, proportionally sized square 3 times the area here? Okay, so let's see what the area is first on this. So it's going to be area equals 5 times 5, or 25, right? Centimeters squared. Now, what if the area is tripled? What happens to the side length? Okay, so the area of the original square is 25 centimeters squared. If the area is tripled, the new area, I'm going to put A in for new area. The new area would be 3 times 25. In other words, 75 centimeters squared. All right, and so it says, so we have a square that is 75 centimeters in length. So if I wanted to find the side length, the area of a square is the side squared, basically. Okay, and so I would square root both sides and get the square root of 75. So the new side length, now we need to talk about this. This is important because you're going to see this on the ACT. All right. So remember we talked about, I think last time we had the square root of 7, some number like this, and I told you you need to break this down into a prime factorization, and you need to find the smallest possible prime that you can put under the radical. And let's talk about how this would work. So what we have is 75 is the square root of 25 times the square root of 3. And so the square root of 25 is 5 square root of 3. So the side length, now let's talk about how this affected the area here, okay? So we had the area originally was 25 centimeters squared. Well, the side length was 5, right? But if I blew up this new area 3 times that, right? We're talking about squares here. So we're going to multiply this by the side length would now be not 5, but 5 square root of 3 on all sides. And it would be the same on all sides in order for it to be a square. So if you multiplied 5 times 5, you'd still get 25. But if you multiply square root of 3 times the square root of 3, you get 3. And so that makes this an entire 75 centimeters squared. All right. So I know we got some messy notes today. We'll go a little slower tomorrow. And I wanted to just zip through this and get, now if you need to on the YouTube video, slow me down and fast forward me however you need to handle that. I'll go over I'll go through the notes real quick with you before we close off. So this is the first half of notes. If you want to, you can pause the screen on the YouTube video here. Okay. And then I'm going to move up. Now, if you want, you can pause the video on the YouTube video here and take notes. And then I'm going to move down to the bottom. So this is the last little bit here. We got to example 3 on section 9-5. So example 2 was talking about the circumference and the area. This needs to be blocked off. Actually, these are 2 separate problems here. So this little corner over here was example 3. All right, and we have a lot of detail in that example 3 in that little corner right there. Okay. So if you want, you can pause the video right there and rewrite that. Okay, so guys, that's kind of it for today. If there's any questions, please ask. I know I went super duper fast, but if you want, go back and watch the YouTube video and turn these in by email or through Microsoft Teams. I'll take it either way, and make sure it's in your own handwriting. And we'll talk more about the next section tomorrow. All right, y'all have a good day.